This was our screen that we left off with in our previous video. Now, we showed that you have two branches of calculus, differentiation and integration, and that integration reverses differentiation, and the integral is called the antiderivative. All right? Now, in differentiation of y equal ax to the power of n, you first multiply by the power, then you get the new power by reducing the old power by 1. Now, what happened in the integration was this. Let me just erase what I have here. So, what you do in integration of a power, you first of all, not reduce, you increase the power by 1. Then the next thing, not multiply, this time you divide by the new power. All right? So basically, just like how when you have y equal a x to the n x to the n, dy by dx is n a x to the n minus 1. When you have y equal a x to the n, the integral of y with respect to x, which is the integral of a x to the n with respect to x, is going to be ax to the n plus 1 divided by n plus 1. You raise the power by 1, you add 1 to the old power to get the new power, then you divide by the new power. Now, last time we said you should add a constant to this, c. Let's look at a few examples. Let me erase some of what I have here and look at a few examples. This was on differentiation. You remember your differentiation by now. Let us just get rid of these notes so that we have more space. Suppose you have the function x squared. You're going to integrate x squared with respect to x. What do you get now? You say x to the, you increase the power by 1, is 2 plus 1, divided by, and then you divide by the new power, 2 plus 1. And you add the constant of integration, which is x to the 3 over 3 plus c. Alright. Now, before we look at further examples of integration, suppose we look at differentiating this. We say y is equal to x squared plus 3. What is dy by dx? dy by dx is equal to, it would be 2x. Just like that. 2x. Good. Now, let's take 2x and integrate it. We're going to integrate 2x dx. What do we get? We say you have 2x, you add 1 to the old power, remember x meant x to the power of 1, you add 1 to the old power, then reduce, then you add 1 to the old power, then you divide by the new power. So you add 1 to the old power to get a new power, you divide by that new power. Alright, what do you get here? It's 2x squared over 2. 2 cancel 2, so you have x squared. Alright, good. Hold on. You differentiated x squared plus 3 and you get 2x. But when you integrate 2x, you did not get x squared plus 3. Interesting. Let me see something else here. Let's do a few more. Suppose you have y equals x squared plus 4, y equals x squared plus 5, y equals x squared plus 6. Well, now, let's see what happens in these cases. You know here that dy by dx is equal to 2x, and that's it. In this case, dy by dx is equal to, it's 2x again. Suppose you differentiate this. Dy by dx is equal to, well, it's 2x. Remember, when you differentiate 3, you get 0. When you differentiate 4, you get 0. When you differentiate 5, you get 0. Y equals x squared plus 6. dy by dx equals 2x. All of these would be plus 0, but you don't bother to write the plus 0 there, right? But the thing now is this. If you're ready to integrate these things, what you get when you integrate 2x dx. A while ago, we showed that when you integrate 2x, what you do is say 2x to the 1, you add 1 to the old power to get a new power, that's 2x to the 1 plus 1, divided by the new power, 1 plus 1. So this would be 2x squared over 2, which is just x squared. So it's x squared. Alright? When you integrate 2x, it's the same x squared you get. You integrate this 2x, integral of 2x dx is x squared. When you integrate this 2x, you get x squared. So it's x squared in all of them. But the thing now, if you differentiate x squared, if you differentiate x squared, you get 2x. Hold on, look at this now. What we had was y equals x squared plus 3. When you differentiate, we got 2x, then when you integrate, we didn't get back 2x plus 3. Interesting. We differentiated x squared plus 4 and we get 2x. And then when we reverse it by integrating, we got x squared, we didn't get plus 4. What happened to the plus 4? X squared plus 5, we differentiate and we get 2x. And then when we integrated 2x, we get x squared, but we don't see the 5. We don't see the 6 here either. Well, now, what we can say about this is, if you get 2x to integrate, you don't know if another number was added to the 2x. Like it was when you integrate 2x and get x squared, how do you know that it wasn't x squared plus 3? How do you know that it wasn't x squared plus 4 or x squared plus 5 or x squared plus 6 or x squared plus any other number? Right? You did not see what happened before, so how do you know that it wasn't one of these? Alright? What you do, instead of worrying about what number, if there was a number added to the x squared, you just put plus a constant, plus a constant, plus a constant, plus a constant. Alright, so good. That gives us some idea right? Why we put the c? In this case, the c was 3. In this case, the c was 4. In this case, the c was 5. In this case, the c was 6. It's just that you aren't given enough information yet to know what exactly x squared was added to. So you put x squared plus c. So that's the constant of integration there. So you must always put plus c, plus k or whatever it is, plus some constant. After you integrate, you must put the plus, well, in my case here, the plus c. So remember, to do it, it is the derivative of 2x is x squared plus c. Alright, so we'll continue this in other videos. So I will see you in the next video.